Welcome and thank you for joining us today. We are Syndicate 3. Today we delve into the fascinating world of innovation and its pivotal role in a technology-driven company such as Intel. Innovation is not just about coming up with new ideas. It is about making those ideas come to life. It is about pushing boundaries, challenging the status quo, and daring to dream big. And for a company like Intel, it is about using these innovations to create a brighter and more technologically advanced future for all of us. Thank you for joining us on this journey of exploration and discovery. We are Syndicate 3, and we hope you have enjoyed our presentation on the power of innovation. Meet our team, Fahmi, Citra, Irvin, Joseph, Rizky, and Efri.
Imagine a world where your brain could directly communicate with a digital device. Could Intel, a global titan in the technology sector, be the one to bring us this revolutionary technology? Welcome to a journey through time, tracing Intel's innovations and pondering its role in the future of technology. The story begins in the year 1968, when Intel was founded in Santa Clara, California. The primary vision? To create semiconductor memory products. Little did the world know this vision would change the personal computing landscape forever. Fast forward to the year 1971, Intel introduced the world's first commercially available microprocessor, the Intel 4004. It was a 4-bit central processing unit, CPU, designed for calculators, but its impact transcended far beyond. It became the blueprint for the modern computer. Then came the Intel 8080 in 1974, a microprocessor that set the stage for the personal computer revolution. It was the brain in the first successful commercial microcomputer, the Altair 8800. The innovation streak continued with the Intel 386 microprocessor in 1985, a 32-bit chip that introduced the world to multitasking. It was a game changer, allowing users to run multiple applications at the same time on personal computers. In the 21st century, Intel raised the bar with the Core series of processors. Designed for high-performance computing and gaming, the latest generation, the 13th Gen Raptor Lake series, features a hybrid architecture for optimal performance and power efficiency. Intel also made strides in the server, workstation, and data center space with the Xeon series of processors. The Sapphire Rapids series, the latest in this line, supports up to 112 cores and high-speed DDR5 memory. Not forgetting the budget-conscious consumers, Intel introduced the Celeron and Pentium series, designed for budget PCs and laptops. These series brought computing power to the masses, making technology accessible to everyone. Intel's innovation even extended to graphics with the Iris Xe series and memory and storage with the Optane series. These products, coupled with the Atom series for low-power devices and embedded systems, round up Intel's extensive product portfolio. Today, Intel faces fierce competition from other tech giants like Samsung, AMD, and Nvidia. Yet it continues to hold its own, standing as the second-largest semiconductor chip manufacturer globally. Now imagine a future where Intel develops a brain-computer interface, enabling direct communication between the human brain and digital devices. Could this be the next step in Intel's innovation journey? Only time will tell. To summarize, from the world's first commercial microprocessor to possibly developing a brain-computer interface, Intel's journey has been one of constant innovation. It has shaped the past, is shaping the present, and will likely continue to shape the future of technology. The world waits in anticipation of what Intel will bring next.
What if the future of human-computer interaction wasn't about typing on keyboards, swiping on touchscreens, or speaking to voice assistants? What if the future was about directly linking our brains to our devices? Welcome to the intriguing world of brain-computer interfaces, or BCIs. In essence, a brain-computer interface is a direct communication pathway connecting the human brain with an external device. This isn't science fiction. It's a real and rapidly developing field that could revolutionize how we interact with technology. So, how does a BCI work? Well, it's all about the brain's electrical activity. Our brains are filled with neurons, nerve cells that transmit information in the form of electrical signals. BCIs can capture these signals and translate them into commands that can be understood by a computer. Imagine being able to control a drone just by thinking about it, or typing on a virtual keyboard purely through thought. This is the potential of BCIs, But it's not just about convenience or cool gadgets. BCIs have the potential to transform lives. Take, for instance, the field of medicine. BCIs could be used to help people with paralysis regain control over their bodies. By connecting the brain to a robotic limb, a person could think about moving their arm, and the robotic limb would move. BCIs could also offer new ways to treat neurological conditions like epilepsy or Parkinson's disease by monitoring brain activity and delivering targeted electrical stimulation. And then there's the potential for enhancing human capabilities. Imagine being able to learn new skills or access information directly from the internet, Matrix style, or experiencing virtual reality not through a headset, but directly through your brain. But let's not get carried away. Implementing BCIs is no small feat. It involves cutting-edge neuroscience, complex engineering, and careful consideration of ethical issues. Privacy, for example, takes on a whole new dimension when our thoughts can be read by a machine. Yet, the potential benefits are too significant to ignore. Brain-computer interfaces represent a new frontier in human-computer interaction. They could change how we communicate, how we work, and how we live. They could help us overcome some of the most challenging problems in human society, from mental and neurological disorders to sensory impairments and communication barriers. The future of human-computer interaction is likely to be far more intimate and powerful than anything we've experienced before. With BCIs, we're not just using technology, we're merging with it. The implications are profound, the possibilities are vast, and the journey is just beginning. So stay tuned and keep an open mind. The future is closer than you think.
Brain-computer interface can be classified as a radical product innovation, according to Trott, 2017, who defines it as a new product or service that creates a new market or industry by offering superior performance or value to customers. This innovation can also be considered as a disruptive innovation, according to Christensen, 1997, who defines it as a new product or service that initially serves a niche market, but eventually displaces established competitors by offering lower cost or higher convenience. The strategy to execute this innovation could be based on the lean startup approach proposed by Ries, 2011, who suggests that entrepreneurs should test their assumptions and learn from customer feedback through a process of build, measure, learn cycles. This strategy could help the company to validate its value proposition, identify its target market, and iterate its product features based on user needs and preferences. The success of this innovation project could be measured by using the innovation metrics framework developed by Davila et al., 2006, who suggests that innovators should track 4 types of indicators: input, output, process, and outcome. Input metrics measure the resources invested in the project, such as time, money, and talent. Output metrics measure the results achieved by the project, such as patents, prototypes, and revenues. Process metrics measure the efficiency and effectiveness of the project activities, such as ideation, experimentation, and validation. Outcome metrics measure the impact of the project on the company and society, such as customer satisfaction, market share, and social value. This innovation is categorized as a technological innovation, which is defined by OECD 2005 as the implementation of a new or significantly improved product, good or service, or process, a new marketing method, or a new organizational method in business practices, workplace organization, or external relations. This innovation involves the implementation of a new product, BCI device, and a new process, BCI technology, that are based on scientific and engineering knowledge. There are some possible non-technological innovations that can be added to this innovation, such as a new marketing method that uses viral campaigns, influencer endorsements, or gamification techniques to attract and retain customers. A new organizational method that uses agile teams, open innovation, or co-creation models to foster collaboration and innovation within and outside the company. A new business model that uses freemium, subscription, or platform strategies to generate revenue and value from BCI technology.
Brain-computer interface is based on technology management. This involves acquiring, deploying, and exploiting technological resources to create value for customers. The goal is to identify and exploit a technological opportunity that can give the company a competitive advantage. To manage this innovation, Intel can use the technology strategy framework proposed by Bergelmann et al. This framework suggests considering 4 dimensions of technology management: technology scope, technology sourcing, technology exploitation, and technology timing. Technology scope refers to the range of technologies the company should pursue or avoid. Technology sourcing refers to acquiring or developing technologies internally or externally. Technology exploitation refers to using or protecting technologies through patents, licenses, or alliances. Technology timing refers to adopting or introducing technologies earlier or later than competitors. This innovation also involves R&D management, which is the process of organizing and directing resources towards generating new scientific and technical knowledge and transforming it into products and processes. R&D management is crucial for developing and testing BCI technology and its applications. To manage the R&D process effectively, Intel can use the stage-gate model proposed by Cooper. This model suggests that R&D projects should go through stages such as idea generation, feasibility study, prototype development, and market testing, separated by gates that involve go-kill decisions, prioritization criteria, and resource allocation. The stage-gate model helps reduce uncertainty, risk, and waste in the R&D process. Various actors are involved in the R&D management of this innovation. Universities provide scientific expertise and access to human subjects for testing BCI technology. Governments provide funding and regulation for developing and deploying BCI technology. Industries provide components and materials for BCI devices.
Imagine a business model for such an innovation for a tech giant like Intel. The business model canvas, a strategic tool for developing new business models or documenting existing ones, can help visualize this. Firstly, the key partners. These include universities and research institutes, suppliers of components and materials, and regulatory agencies. Each partner plays a crucial role, from providing scientific expertise and access to human subjects for testing, to ensuring the safety and ethics of this cutting-edge technology. Next, the key activities. Developing and testing BCI hardware and software, conducting market research, and promoting the technology are all pivotal to the success of the venture. The value proposition offers a novel way of interacting with technology, providing superior performance compared to existing alternatives, and creating a network effect that increases the value as more users join the platform. The customer relationships are built on trust and loyalty with early adopters and providing personalized support and guidance. A community of users can share their experiences and feedback, further improving the technology. The customer segments range from a niche market of tech-savvy customers to a mass market of mainstream customers looking for a lower cost or higher convenience of human-computer interaction. Key resources include the human resources, engineers, scientists, marketers, and more. Intellectual resources like patents, trademarks, and know-how protect the technology, while physical resources like devices and servers enable it to function. Channels for marketing and dissemination include online platforms, offline platforms, and word of mouth. Each channel serves to showcase, demonstrate, and spread BCI technology. The cost structure consists of fixed costs like salaries and rent, variable costs such as materials and distribution, and the economies of scale that arise from producing devices in large quantities. Finally, the revenue streams. These could come from sales, licensing, or advertising on BCI devices or platforms. In summary, the business model canvas for a brain-computer interface innovation at Intel would involve key partnerships, activities, and resources. It would provide a unique value proposition, foster customer relationships, target specific customer segments, utilize multiple channels, maintain a balanced cost structure, and generate multiple revenue streams. This comprehensive approach would help usher in a new era of human-computer interaction, changing the way we interact with technology forever.